Hello, viewer. Welcome once again to my new screencast. My previous screencast was the concept of microservice and the microservice exposed via by using the RESTful API. The requirements that's we had it. The client says that we need some microservices uh, to do some health service application, and we did it our the health service RESTful API based on the MySQL SQL based database MySQL. Then that client has a different requirement. They said they needed another version of this API with non-SQL database. And then we make a plan. Okay, we have different non-SQL database option like MongoDB, Cassandra, Redis, Gamefire, and Elasticsearch. And after the discussion with the requirements, and they said, oh, okay, we can start with the MongoDB to give the initial release for those API uh, to use the web development teams, or to deploy this API to use the third party or third company, this one. So if you see the diagrams, the last screencast was about the MySQL based. I did the release, and then there is a the we did all the development. We configure our application and put this application to the different environment. From that means from development to test environment to quality assurance environments, and then quality assurance the production environments. So just go my last screencast number 26, and then look for that one, and then and and this screenshot is more or less about the same things in the same data models and same domain model, but in the backend server is different. The backend server is MongoDB. So the same functionalities we try to transform from 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 MySQL from the SQL world, as like MySQL, to the non-SQL world, to the MongoDB world. So the functionality is still the same, but the backend server is the same. The backend server is different. So that means that your installation process should be same. Your deployment process should be same. The configuration process should be same, but the configuration properties will be different, and your backend is in my MongoDB database. So in the last screen, a lot of viewer asking me to give them some explanation about the Spring Boot annotations. Those we are try to use in our application. That's why I try to give them some brief explanation about the annotations, Spring Boot annotation. Let's start to give some overview about this explanation. So it was the data requirement was the API should contain the demographic data set, administrative, health, and patient and medical management data sets, and also the address, location, and user registration data sets. So all should have contained those information in the API. So is the component annotation. You say the component is generic annotations, and it's composed is to be this annotation to be detected during the component scan process and registered as a Spring Bean. So that means when you your class Java class, this is the class level annotation. So when you annotate the class this one, then that means that the is automatically detected as a Spring Bean. So you see the repository and the service and configuration and controller are the meta annotation for the components. So this is the core annotations, or the base annotation for other 4 or 5. So service annotation is also the in the class level annotation and the class path auto scanning, and basically it's we use for the class containing the business logic for an applications. So by using the components on the service class instead of service, so you can use the components or you can service. So there is no harm, but it is better to readability. That means in the class which is containing our business logic, it is better to that annotate as a service. Then everybody or the code or your understanding is clear that this is the service class, and is containing all the business logic for an application. Service is a specialization of the components. So is it the repository? So basically the repository, when you try to store or patch or search data, come to the that means the repository means the this functionality has to come to this category. And then basically when you try to DAO or data access object actions or operation or data access layers in applications, then that case we use these annotations. You see that the repository is a specification of as a component annotation. So component scan, that means it defines the readability of the component for your auto scanning. Back is a base package name, ensure the classes annotated with the and the component annotation found the register as a Java bean. So it's look like it's registered the Spring Bean when you annotate your class as a component scan. So controllers is all of the controller is a really core annotation for the Spring MVC framework. Then that's why is the technology, while the traditional MVC controller lies on the view technology. So means the controller did when the request come and it's process it and it responds in the view. And the difference between the REST controller, its response as the response in the HTTP response as a JSON or XML format. That means is a REST response is not the view response, is a REST response. So that means there is a lot of flexibility, but of course depending on the application. So for this annotation is really important for us, because we are exposing our domains as a REST API. So that's why this, when you use this annotation in the class definition, you don't need to return the response body, because it's the annotation is cover all of them. So request parameters is just to bind your web parameter to a method parameter or method variables. A response body, as I said, the response body is a view technology or JSON or XML response objects. In the view, in the response body, you can also contain the context path and also the HTTP header, and here you see the HTTP response body also together. So the path variable indicate the method parameter should be bound to the URL template variables, and then it bind the URL template path variable to the method variable. So that means in the your method, in the your resource or your endpoints, method parameters is bind to the request parameter. So request mapping is both is possible to put it here, the class level and also method level, used to the map the request onto the specific handler class or handler methods. Use as a class level is create a URL for which the controller will be created. So that means it's defined how your URL request mapping has to be done, and how is this mapped, or how is bind. So AutoWare is in general is applied on the fields or setter methods or constructor, inject object dependency implicit. So force constructor on the method needs to execute after dependency injection is done to the perform any initializations. So that's the annotation did. The method is called after the class path being Java class is initialized. Value to annotation is for reading the properties value properties as like the application.properties file. You try to read some key values from the properties files. And configurations is one of the key annotation for Spring Boot framework. There's a class level annotations, and the method to indicate and configure dependency normally with the bean annotate methods. The bean is a similar process for components. It is not auto-directed. This is the main difference between the components and then bean. Bean is a method level annotations, and that means the method is a level annotation. Bean works with configuration to create the Spring Bean. So this is the Spring Boot application annotation. This is the heart of any Spring Boot application. It is composed all other annotation as like the configuration annotation, component scan, enable auto configurations, everything together. If you annotate your Spring Boot application, then it's automatically handle all down level configuration, auto configuration, and component scan. And see that the other most important Spring Boot annotation in the Spring Boot frameworks. So let's see in the practice, in action, in our application, which annotation use where and how. So let's start to generate our Spring Boot applications via Spring Boot application initializer in the So here is the Spring Boot initializer. So we set it as a Maven based project, and you can set it also the Gradle based project. So for us it's this Maven based project, so you can select the languages Java, Kotlin, and Groovy, and which is a Java, and then we set it's the version of the Spring Boot, and then you can put it here your application group ID as like our group name and the application name. So the previously what was MySQL HS means the health service API, and you can name it like as the artificial name. And you can search also here from the web. We need a web dependency, we need a REST, and then REST repositories, and you can pop down. Okay, we give the descriptions. So, and this is the most important part. So our application is a executable jar file, so we select our packaging system is jar, and there is another option is where, so they can select from here in the Java version. So we use the Java 8 version. So as you see, you can select from here the select checkbox in the DevOps tools. That means these tools did you automatically compile your source code and execute your source code when you change something. This is important tools for the Spring Boot developer. So we already selected the web and the REST repositories, and go the further. So we are in the NoSQL database. So we select Mongo, not embedded Mongo, just the Mongo. So we need the actuator. And this is the actuator. So that means the actuator did was your endpoint. The endpoint informations for your application, like the health condition for your applications, info of your application, logging information, then the metrics of your application. This is the actuator, what the actuator did. So then we needed shorter versions. So let's see the shorter versions. Then you see, even though you can select from here too. So then generate the projects, and project generation is done. Then we need to download the projects and try to import the project into your respective IDE. So a lot of the viewers asking me why I can use at the time the STS tool is being development tool suites, and they said why not the IntelliJ. So I tried to integrate the IntelliJ IDE to implement my application with by IntelliJ. So what I did, just I already did the import in the application into my IntelliJ IDE, and you see the application is there. So you can do like the file and new project from existing resource, and of course you need to unzip your applications first and then just import it, and that's all. That's automatically IntelliJ. IntelliJ is really good IDE for the developments. I use the community version here. So the project is generated and unzipped it and into my local systems, and then I import the project into my IntelliJ. So you see all the project is there, and then this is the standard structure. Just I said many of my videos, and then as this structure, I love it. This is the structure for the professional life. Everybody use it. So they just follow that one is a professional one. So you have to be model package is containing all your domain models, and repository containing all the repositories for your applications or your REST services, and resource is containing your all the resource definitions. That means that your URL endpoints. Then service containing your service definitions, service implementations, the interface, and then the service implementation is as like Spring Convention service impl. So then put it here, your all implementation, this one, and then this is your main applications. So see, this is we already talked about this one. This is main annotations like Spring Boot annotations, and then we enable the Mongo repository because we are working with the Mongo database. So let's have a start to look for our domain structure. So the last time I already said there is a simple. There was the application was MySQL based. Now is application in MongoDB based. So it's a different data model. This is different annotations, and this is the different mapping structure. That means we need to not really remodel it. We need to recoded it or decoded it. This the application models. So I will show you the parallelly what's the change, what has to be done based on the MySQL or based on the MongoDB. So because you know the SQL world, there is a standard process. So whatever it is, you are using MySQL or Postgres or MS SQL Server, Oracle, doesn't matter. If it's relational database and SQL database, and then there is only annotation is enough for all of them. But in the non-SQL world, every non-SQL database has own annotation, own modeling structure, own modeling way of doing. So that's why we have to understand what's the difference between the SQL based data modeling, the ORM modeling, and also what's the difference between the non-SQL data modeling, I mean the ORM in respect to the MongoDB. If you see that the models of all the requirements models are here, I will show you all of them. So give it to you the very first overview. What's the difference between that? So here is we see the difference. We annotated documents. It's a documents. Is this like a documents is equivalent to the entity. and collections is equivalent to the table names. So here is the administrative info, and we annotate this way. So exactly the same situation here is the ID is the primary key, and then all the parameters. If you compare with these models, this MySQL based annotation model, the MongoDB annotation model against the MySQL based on model, the previously I have it in here, you see the difference. So entity and tables, and then so here you see the relationships. So one to many relationship, and many to in the other side is many to one relationships. So it's the same models, but is differently designed or differently annotated these models, because this is the SQL world and the Mongo is a non-SQL world. So that is the standard. But if it is a non-SQL world, if you try to transform this model based on the PostGIS, is simply you just need to change your database properties files, the configuration, everything should work automatically. But in the non-SQL world, it shouldn't be possible to work one-to-one or work directly to transformations. So here is the annotated it, and then this is the below. You see the administrative info has the address location, maybe the address location in the international company they have in Bangladesh or India, Pakistan or Germany or USA, and that's why there's multiple address location. And one administrative info has a multiple patient information, because if you have insurance company and there's an administrative unit, there's a multiple many patient information is there. So it's a one to many related this way. So you see there's no annotation because of the non-SQL world. So here is the same thing. We annotated like address locations, and address location containing all our respective information. Where the district, city, or province, or country, or street name, even though in the latitude, longitude, where exactly is geographical locations. And then it's important take the pictures where exactly your address located. So you can make a Google Maps and take a pictures and put it there, and it works. So that means address location has a multiple administrative info and demographic info. Demographic means the peoples, you consumer service consumers informations, demographic information. So you see that demographic informations we annotate like this way as it is, and then get all the information, the first name, last name, and age, nationality, and the birth certificate. You can put it here, scan the birth certificate and put it there, and even though passport copy, and take the pictures, put it there here. And here is the locations. The address is important because where the people is living there, and how they are how we provide our services. That's why the location information is really important, and this is one of the key information, a key requirement from the product owner. Says, okay, we has to be think about, because later we have to be process some geographical processing, where exactly located our services, service consumer and service provider. Then we can provide geographically, we can maintain and manage and monitor geographically our applications, our consumer and our supplier. That's important. So here's the health information for each of the patient, and then you have less information here. This is because I said this is our really initial release of this API for this customer. And there is a medical management informations. You see all the units of informations, who is the supplier, who is the when they supplied the medicine, and then there's some remarks and description of the user, how they use it, and duration of the use of this medicine, and blah 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 of this information. So here's below is the standard getter and setter methods. So you see the the patient has a multiple medicine information. So maybe one patient has a disease information, and one different disease has different medicine management. So I mean, even though the different medicine scheduling, how long he or she will take this medicine, and then how it has to be taken, and then all has to be handled with these models. the patient informations as it is. The patient has a demographic information, he has the health information and medical management information. So all are joined, all are together, is a link together. And yes, of course we can make it like make it another way to do the microservices. Maybe it will be the next requirements. That's we don't know. But the initial, that was the discussion. User registration, this means that user has to be maintained. Each of the user, whatever it is, the administrative user or consumer or supplier, doesn't care, but it has to be handled as a logging mechanism. So it has all user has a user role as it is, that's something as a role, and then feed it the role. And that means when the role is started, which type of role he has it, and when he start his job or works. So as this all our model definition is done. Now we need to do something and we has to define our repositories. So here is see the repositories as the exactly same thing. We did the repositories is a default REST repositories, and then sorry, I forgot to give you the definition of the repository REST resource repository REST resource. It means if you annotate any interface, then the systems automatically define your endpoints, means all your URLs with CRUD operations. So that means we use extend our paging sorting repository for the address location information, and our URL path this is the URL path. You have to be like HTTP, localhost, your machine number and the port number, and then your URL path, and then you do your CRUD operations, and whatever it is, create, update, delete, and then that's so on so forth. So, and here the same thing is same definitions, and here is the paging sorting health information. So health information we did it at CRUD operations without default, and just like initial, and this is also the one of the default repository, and then here, and then here. So here is the more special one. So we extend the CRUD repository. We have a repository, so we try to customize this repository our own way. So that means you have more control your operations. You can do whatever you like to do. So that's why we try to give some input or some extra control for this repository, user registration repository, because this is the logging part of the applications. We have to be maintain a lot of things, security part, logging part, and it's really important. That's why we try to control ourselves. So here's the default settings. You see the repository, and here is the service definition that we try to control. So this is the own definition our service. You see the annotation is service annotation. That means this interface, the class implementation should contain our all business logic. That's why the lot of viewer says please explain the annotation very shortly. That's I try to do. And then this is our implementation for this interface. You say that all implementations we extend implements our interface, our own interface, and we do the control of them. So here is a CRUD operation. You can look for that one. And here is our CRUD operation. Here is our resource definitions. So this is the endpoints. So this is the endpoint definitions. So user registrations, and then we did the endpoints and the CRUD operations and in our own way. So you see the request mapping is there, and method is get, post method and get methods, and then delete method and put method somewhere is a put method. So response entity is return value. So you have more control about our endpoints. So then this is our model definition is done, our repository definition is done, our resource definition is done, and then our service definition done, service is implemented is done. Now is the most important part, because we said our application is really has to be externally deployed. That means we need to configure our resources for deploying our application from environment to environment. So that means in that case, the last screencast I already said we use the concept of the Spring profiling concepts. So that means in the resource definition we need the 4 or 5 files, how many environment you have it. So you see, if you close look in this one resource, and this is our default applications, and application is, this is the application, they start with the port number at port number 2525 and localhost and the your application name, and then this is our database, the Mongo database name. And remind that this one, if you don't create the MongoDB database before running this application, the Spring Boot application automatically generate your database automatically. So our Mongo is running our local host, and this is the port number. So as it is, that's we have it in the in the application.deb. That means the development environments. We try to put it, means this is the configuration, the keys we try to override externally. I will show you how can we do it. This is the developments, and this is the productions and production, and here is the QA, and here is the rel, and then here is the test environments. So even though there is a test development environment, you can write it down. So here is the doesn't matter. So it's just like development, because we will change it in the externally, this configuration files. So that means this is simply copy of your default one, and then we try to we try to override from externally. So what I did, just I build the project generation is done. Just you can go there and Maven and install your projects, and project is, and I already did the generation of the application. So you see here is our executables are files, and then with the application name, and then your version number, which you provide your pom.xml files, and that's all. So your application is done. So what I did, just I copied it the jar file into the my configuration directory. So here is our configuration directory. We put in my jar file here, and this is our main path we try to run it. So you see, if you see, look for this our environmental configuration script files, and then here, so here your definition where your Java located, and your application port will be started, and the application the local host, and this is the your URL, the application file, even though you can put it your these files, the absolute your relative path of the files, and that's all enough. So this is we try to run very fast our application to the development environments, and this is the port number, and this is our database name of the database name of the MongoDB database, and then this is the service definition. So our application, so read the environmental setting parameters from the env command files, and then run our jar file application with all the settled properties from these files, and this is one of the files. Of course, you need to start your MongoDB first. So I will show you how it starts the MongoDB. So you see here that our Mongo is installed, and now we need to in the CMD. So Mongo is installed in the D here. Then you need to run your Mongo server, MongoD, and so it will be the Mongo database server in the behind. So I started the Mongo server, and now we try to start our applications. So we started our application. So first we try to run our application in the development environments. So that means start start our start service. So you see our application is running in our development environment, the port number 2525. So let's have a start our application in the production environments. So here is our okay, we need to change our, because we said our need to change this. So we need to, in the production environment, our application should be run with port number 2626, and then this is the most important one. Be careful that one. So we run because we already configure our application resource files with this and with this key proc. So that means the application now deployed in the production environment. If you put it test, then its application should install in the production in test environment, and QA and release and whatever it is you have, or maybe you have a staging environments, and then you put, and then at the same time you have to change the port number if it's not used anymore, this port number. So that's the port, and we said change this one, and we said it's still the same port, and our Mongo is a local host, and then you can change it here. So and the pro environment. So that's all, the configuration is done. So now application should deploy it in production. The application has to be this port, and this is the database automatically should create in the production environments. And that's in the last video I said there is need to somehow to migrate our database. I will make a new screenshot when I have time. How can you do the migration process from environment to environment as a database administrator? So I will show you, I will make a screenshot for later for that one. So now we try to run our applications to the to the development environments. Here is development. So we change our configuration in the envs and cmd files, and now we start our applications. The application should start the port number 2626 in the production environment. Start service. Sorry. So let's say the application is running port number 2626 in the production environment with the database Spring Boot MongoDB in Pro database. So now start the application need to be tested. So for testing we use the Postman. Postman is a very good tool. You can use the different tools like Soap UI or REST clients or Swagger UI. You can do with this that way. So I found Postman is a good tools, and you can easily export and import your test scenarios or test cases, and even though you can set your global environmental setting, global environment variables. I don't know which screencast I have it. I already describe how can you really set the Postman as a professional way. That is, you can set the global variables, global URL, and then you can run very quickly and professionally your test cases. So let's have a start our testing in the Postman. You see the Postman started. So I already had some test cases. You can do more for what you like to do. So here is the we say here's our the health condition. Is it to check the application is running or not? Let's see, in the development is running. Let's see. So it's your application is up. So you can now you can change it like is it you can duplicate the applications, the test cases, and rename it like. So that means you need to check it. Is it the production is running 2.6? This is the job the actuator did. So even though you can set it your environmental variable that it is. So let's see. Good luck. So both in the production environments and the development environment, both application is running. So let's do some real test. So we did some insert post, CRUD operations with all the respective settings parameters. This is the input, and you see the complex object, and there's address location input, and this is the address informations, and there is a patient information, and then there's inside the patient information there is a demographic information and health information, medicine information. This is exactly the models that you implemented in the implementation stage. So let's have it put it one record into the development environments in development. So development is 2525, and this is the URL already you define in the your definitions. So send to development environments. Yes, perfect. Does the record is generated, inserted, and then with this all informations. So then from here you can get it this record. No, sorry, it doesn't. So it's get the record information 102, this one. So is it possible to update? You can update it. Those values, maybe change it. Sorry. So it's change some values and try to put it. Yes, this is up to date, updated, and then you can get it. Then values get it, and then in the delete you can delete it, and do 2215, and the record is deleted. So now I get it. So it's deleted, no record. So let's do the test in the same test with the production environments. So in the put, we did the put, and all the data is there. And just put it. It's created properly. And is it get it? No, you need to change something. This is the update. Send. So update it, and then get it. Good, perfect. And even though you can do more, more put method. So did it. Created, and maybe delete one of them. 100. So delete all record is gone. So we can do more testing with all the possible load testing or individual microservice testings. What we did just like to checking is it our application is running. So you see the how easy to test this application in the to deploy the application to the development environment, to the production environments, and then how easy to run the test with the same test cases should be run in the production. So it's look like the your Mongo is Mongo server is running, and Mongo that is, so you see our all databases. So we build a database. This is the DB database and the production and the QA and rel, and then test database and the standard database. So you can use one of them, and then the data is there. So it's automatically build your database and generate your collections or tables, or what mean in the documents in the document database. So you can cross check it what data is inserted, and then you can investigate is data properly properly inserted and deleted and updated. This in the command Mongo console. So that's all this video. What now we try to recap it. What we did the two different versions, meaning our application implementation based on the MySQL. That was our previous screencast number 26th, and this is the screencast with the same functionalities, but in the backend is changed. Backend is MongoDB. That means just the backend change, but functionality is in the business logic. The functionality is changed. We have to be redesign only the implementation part, the definition part, or your domain model part. This is the part you have to do because of the database changing, the backend changing. So in the next screencast in our development pipeline, we have some screencast in the pipeline, like the cloud-based application deployment configuration. Cloud means the pivotal cloud foundry, or Google Cloud Platform, or Amazon Cloud Platform, on SAP Cloud Platform. This type of cloud platform, we try to build our application and try to deploy the application into the cloud. That's our in the plan to the next screencast. Maybe more if it's coming soon in the screencast. But before that one, we try to make some another extra screencast for covering the all non-SQL databases like Cassandra, MongoDB. So we did it, and Redix and Gamefire and Elasticsearch. Let's see what can we do for the community. So finally, I only said you could subscribe my channel and press the bell button to get notification from my upcoming videos. And that's all, and today is goodbye. See you later. Bye bye.